So students, already you know what is stoichiometry and how to do the stoichiometric calculations. Now let us solve two questions related to this. Your first question, question number 1, that is how much of copper can be obtained from 100 gram of copper sulfate when the atomic mass of copper it is given as 63.5 U. Now let us see copper sulfate. If you take it 1 mole of copper sulfate if you take, then you see in 1 mole of copper sulfate, 1 mole of copper atoms, 1 mole of sulfur atoms and 4 moles of oxygen atoms are present. 1 mole of copper atoms, the molar mass, the copper atomic mass is 63.5 U. So 1 mole of copper atoms, the mass is 63.5 gram. 1 mole of sulfur atoms, the mass is 32 gram. And 4 moles of oxygen, it is 16 into 4, 64 gram. So in 1 mole of copper sulfate, 63 gram of copper, 32 gram of sulfur and 64 gram of oxygen are present. Now let us find out the molar mass of copper sulfate. Molar mass of copper sulfate, that is equal to 63.5 plus 32 plus 64, that is equal to 159.5 gram. So in 159.5 gram of copper sulfate, 63.5 gram of copper is present. So you can write from 159.5 gram of copper sulfate, we can obtain 63.5 gram copper. So from 100 gram of copper sulfate, we can obtain 63.5 divided by 159.5 into 100. This many grams of copper you can get from 100 gram of copper sulfate. So this was the first question. Quite easy. Now coming to the second numerical. Focus on it. How many moles of methane are required to produce 22 gram of carbon dioxide after combustion? You know children, for stoichiometric calculations, always you need a balanced chemical equation. Chemical equation representing the reaction and also that should be in balanced form. So let us write the balanced chemical equation for this reaction. That is carbon, that is methane, gaseous form, reacts with 2 oxygen in gaseous form, gives you carbon dioxide in gaseous form plus 2 water vapor. So this is the balanced chemical reaction. How many moles of methane this is required? So in terms of mole, 1 mole of methane reacts with 2 moles of oxygen to give you 1 mole of carbon dioxide and 2 moles of water vapor. Now in terms of mass, 22 gram is given here, na? So in terms of molar mass, you can write down 1 mole of methane, this is your 12 plus 4, that is equal to 16 gram. 2 into 32, that is equal to 64 gram of oxygen. And here your 12 plus oxygen 32, that is equal to 44 gram. And here 2 moles of water, 2 into 18, that is equal to 36 gram. So see here children, 16 gram of methane reacts with 64 gram of oxygen to give you 44 gram of carbon dioxide and 36 gram of water. So how many moles of methane are required to produce 22 gram of carbon dioxide? So 44 grams of carbon dioxide is produced from 16 gram of methane or 1 mole of methane. So you can write 44 gram of carbon dioxide is produced from 1 mole of methane. So 22 gram of carbon dioxide will be produced from unitary method, you can write down 1 divided by 44 into 22, that is equal to 0.5 moles. So 0.5 moles of methane produces 22 grams of carbon dioxide. So question is solved. I hope you understood.